Good evening, my dear students. Nan Hesrenu, Captain Shreyas, your physics master teacher, and you are watching Nee Nodtini Vedantu Karnataka channel for all the students of PUC, KCT, and Comet K. After an amazing class of 2-3 mark questions and all the important high weightage topics and the concepts videos, and then all the strategies, a lot of you are also asking, sir, can you do a session on this heavy weightage 4-5 marks questions, because that's where we lose lot of marks. Don't worry, Shreyas Sir ide. We are taking some important questions which are important from your midterm perspective, and let's try to solve as many questions, and one question I'll also give you as homework. All right. So let me know quickly in the comments, where are you from, what's your name, what's your standard right now, are you in 12th or have you taken a drop in case you are preparing for KCT and just watching these videos for gaining more knowledge. I would really be happy to know more about you. These are my details. I have been teaching for quite some time now, and I have trained like thousands of kids and sent them in the top-notch colleges also, even though they were average students. Now here I am to make sure that you get your desired college, desired seat, your dream in this particular year only, without having to struggle too much, in a smart way. Okay, so that's why you should subscribe bega to our Vedantu Karnataka channel, and also bega like Madi to this video, so that YouTube also knows, oh, the student is interested in PUC boards or KCT, right? So let's start with the questions. Thank you for liking, thank you for subscribing, and here is the first question. These are all heavy weightage questions. They take some time to solve in the examination. So let's do it. Two charges are there, 5 10 to the power minus 8, minus 3 10 to the power minus 8, 16 centimeters apart. At which point do you think the electric potential is zero? Take the potential at infinity to be zero. Standard practice. So let's try and solve this question, guys. See, first of all, draw the diagram whenever you have such confusion. 5 into 10 to the power minus 8. Okay. So this is 5 into 10 to the power minus 8. And the distance is how much? 16 centimeters. All right. So 16 centimeters. And the other charge is placed over here. It is negative 3 into 10 to the power minus 8 coulomb. Okay. Now there will be a point where the electric potential is zero. Just to give you an idea of the formula of electric potential. So if you take a charge at some distance r, due to this charge, the electric potential is given by K, Coulomb's constant charge, divided by the distance. If the charge is positive, potential is positive. If the charge is negative, the potential is negative. Now, it kind of makes sense that since this charge will give positive potential, this charge will give negative potential. Somebody is doing good, somebody is doing bad. They will cancel out each other. And totally, I want the total potential to be zero. So let's assume, my dear students, that somewhere in between, maybe somewhere over here, the total net potential is going to be zero. So let's say the distance from this charge, it is x centimeters. So naturally, distance from here will be 16 minus x centimeters. Why 16 minus x? Think, this is 16, this is x, 16x. How much will this be? 16 minus x, correct? So that's why it is 16 minus x centimeters from the other charge. Now, when I try to find the net potential, my dear students, it will be potential due to the charge 1 plus potential due to the charge 2. This guy and this guy. I can call this as charge number 1. I can call this as charge number 2. Both of them will give potential here. Totally, their summing up is zero. Their addition is zero. One is positive, one is negative. It is clearly given in the question. The net potential is zero somewhere. I don't know where it is. So this is 0 is equal to potential due to this charge. Use this formula, KQ by R. Coulomb's constant the charge value, which is 5 10 to the power minus 8, whole thing divided by the distance, which is x, plus k into q. K is again k only. Q is negative 3 10 to the power minus 8, whole thing divided by the distance, which is 16 minus x. Since this is negative term, bring it on this side. It will become k multiplied by 3 into 10 to the power negative 8 divided by 16 minus x. Whole thing I have shifted it on the left hand side. Keep it as it is, k multiplied by 5 multiplied by 10 to the power negative 8 divided by x. I hope this is absolutely clear. Now you might be wondering at this point, sir, you made a mistake. Sir, this was in centimeters, sir, you had to convert it into meters. See, I'll tell you what, there is no need to do that. Why? Even if you do, there is no change, because if I convert this centimeter into meter, here also I have to convert centimeter into meter. So both the sides, when I do the conversion, that conversion factor on both the sides will get cancelled. So it's okay in this problem to not convert, because RHS, LHS, here also left hand side was 0 only. So it doesn't matter, the RHS, LHS, the factor of conversion anyways gets cancelled. Now, when you're solving, always show it in pencil. What have you cancelled? Okay, I'm cancelling k. I'm cancelling 10 to the power minus 8. Okay. So now the next step will be, after cancellation, cross multiply. 3 into x. See, 3 multiplied by x is equal to 5 multiplied by 16 minus x. Now rearrange it slightly better. 16 5s are good. This is 80 minus 5x. Take it over here. 3x plus 5x. 3x plus 5x is equal to 80. 3 plus 5 is 8. So 8x is equal to 80. Therefore, x is equal to 10. But what is the answer going to be? Everything in centimeters. So our final answer that we will write the answer is 10 centimeters from 5 into 10 to the power minus 8 coulomb. If this is 10, how much is this? If this is 10, total is 16, this is 10, this will be 6. So 6 centimeters from what? Negative 3 into 10 to the power minus 8 coulomb. The net potential is 0. The net potential is basically 0. That's how you will leave the final answer. Is that absolutely clear? That's how you solve the question. All right. So solution, everything is mentioned again over here also. Yeah. 6 centimeters or 10 centimeters from this charge. Fair enough. Good. Let's go to the next question. Derive an expression for the electrical conductivity. Basically sigma in terms of the time constant and all of that. This is a very popular question in current electricity. I'll show the step-by-step derivation. Everything that has to be written in the derivation, I'll show all the important points. Description part, you can write it, where I is current, tau is relaxation time, blah, blah, blah. You explain those things in detail. I will show you all the important steps so that in your memory it is built up. Okay, so let's start. The first thing that you will do is derive the formula. Current is NVIDIA. It's a big question. So you have to start with that particular derivation, my dear students. So first you will say, take a part of the conductor whose length is basically L, area of cross section is A, and there are number of charges in it. These charges are moving with some speed called as the drift speed. And because these charges are moving right side, and all these charges are, do not forget, negative charges. So the current will be moving in this direction. This is the current. And to go from here to here, imagine it takes some time. We will assume all those things. So current, which is there, it is nothing but the charge which flows upon the time which it takes to flow inside that particular conductor. Now, how much charge is there? Just imagine all this charge just comes out. Whatever this charge is there, imagine that charge comes out in some time. In time of t, the whole thing has come out like this. So how much time it has taken? We have assumed it as t, which is over here. The charge which goes is given by, in this, each charge which is there is an electron having a charge of E, but there are many such electrons. So I will write it as number of electrons into each charge, which is basically E. E is 1.6 10 to the power minus 19. N is the total number of charges. This is the total number of charges. So charge which flows per unit time. Charge flown is NE. Time taken to flow out is basically T. Okay. Then what will you write N as? There is a very interesting thing. I can write it as small n into the volume. Small n into the volume. Yes. You will be wondering, what is this small n? See, this small n is the number of charges per unit volume. It is basically also called as the charge density. The charge density of a material. Number of charges, hundreds are there in 1 meter cube. So small n is 100 per meter cube. So capital N is small n into the volume. What is the volume of that conductor? You will write it as area multiplied by length. Area multiplied by the length. So therefore that is basically the current. What is the length divided by the time? What is the length divided by the time? Think about it. Length divided by time. Length, time taken t, is the speed. The speed with which it travels. So basically n, this will be drift speed into E into A. So L by T is the drift speed. So I get current is NVIDIA. This is the first step of the problem. Okay. Now after this comes the next step. After this comes the next step of the problem, guys. So again, let's say for example, you show this particular conductor. Let's say there is electric field. Oops. What just happened? There is electric field, let's say, inside that particular conductor, because of which the current is going like this, whereas the electrons which are there, they are moving like this with some drift speed. Each electron is going like this. Okay. Next comes the concept of that electric field. Observe this carefully now. What you do in such cases, you will say that these electrons, after collision, they lose all their energy on an average, have no velocity, and then what happens is they begin to accelerate, and then they again get some speed, and again they will collide, basically collide, and the same process repeats. Zero speed, zero speed, zero speed. This keeps on repeating again and again. So in this process, the electric field has applied that force because of which it is accelerating. So there is some acceleration which is given by the force divided by the mass. The force is the charge multiplied by the field. That's the value of the force, charge into field, and this whole thing divided by the mass. The charge is the electron charge, the field is the electric field, m is the mass of the electron. That is your acceleration. Now use kinematic equations, you will get the drift speed formula. Vd, V is equal to U plus AT if you use on an average. The average speed will then become your drift speed. The average initial velocity after collision is 0. The acceleration we found out over here, E by m. The average time from one collision to the other collision, that is called tau, which is called as relaxation time. So we get this. Substitute that in the previous equation. So therefore, Therefore, current is equal to NVIDIA. NVIDIA. Okay, so current was NVIDIA. VD is E. What is it? Tau is there over here. E by M tau. That is your drift speed. That is your drift speed. And that E from before is also there and A is also there. I just substituted drift speed over here in the previous equation. In the previous equation. So what do I get from this? Check this out. Current is equal to N is there. E square is also there. Electric field is there. Tau is there. A is there. Whole thing divided by M is also there. Whole thing divided by M is also there. Okay, everybody fine? N, E, small e square, capital E, tau, A and by M. Okay. Next step, take that area below current. Current upon area is N, E square by M tau, and this electric field you put it separately. Now I'll tell you what happens in the next step. Observe this carefully, guys. Let me just, if you want, just take it on the other side. Let me just take it over here. Just observe this now. I've just taken it over here. What is current per unit area? That is called as current density. That is called as current density, J. That is called as current density, my dear students. Okay, what is electric field written down as? Electric field, can I write it as something else? Yes, definitely. It is Ne square tau by M. This, my dear students, did I forget? Yeah, A is also there. Okay, fine. Yeah. This electric field, why not write it down as, J rho? Remember, there is an equation. Or you can just write it as, just do one thing, simple thing I'll tell you. Remember, electric field is potential difference per unit length. If the voltage difference is V, distance is L, so it is V by L. So instead of electric field, put V by L. Put V by L over here. Now I'll tell you what happens in the next step. You can write this as, therefore, J is equal to Ne square tau by M. This L is there. Voltage is nothing but, current into resistance. Next step, what you can write this as, J is equal to Ne square tau by M. This L is there. Current is there. Resistance is rho L by A. L and L gets cancelled. Rho L by A. Yes, this length and this L gets cancelled. What is current by area? It is basically J, guys. So Ne square tau by M. Current by area is J, and this rho is there. J gets cancelled. So I will get, therefore, 1 by rho is equal to Ne square tau by M. J and J just got cancelled. I will just write it over here. J got cancelled. Here LL got cancelled. Perfect. So 1 by rho is equal to this. What is 1 by resistivity? What is this rho? It was resistivity. So that is basically sigma, which is Ne square tau by M. Remember, this rho over here was resistivity. What is this sigma over here? 1 by resistivity is called as conductivity. Examiner will be fully impressed that you wrote all the steps, everything from the start. The examiner will give you sure shot 5 marks. 5 marks you will be given. You derived current is NVIDIA. Next step, you got drift speed in terms of relaxation time. Current by area, you wrote it as current density. Electric field, you wrote it as potential difference per unit length. Ohm's law you used. Everything you cancelled out and you got the answer. Is that absolutely clear? So that is the derivation. You can play around with it and get it in slightly different ways also. That is what they have also eventually done. Okay. Derive the expression for the magnetic field on the point of an axis of a circular loop. This is also a very popular question. So let's understand this. Say for example, this is our loop. This is the radius of that loop, and you are on the axis of the loop somewhere over here like this. Let's say this, I call it as x. Let's say this is the radius of the loop. This is how the current goes in that particular loop. I want to find the magnetic field here. You start by Biot-Savart's law. So take the topmost element, the topmost wire. Just think about it. The topmost wire, small element, has a current which is coming towards you. Has a current which is coming towards you. It is going like this, going in, going from behind and coming towards you. Visualize this in 3D. It is coming towards you. The length of the element is basically dl, and it is coming towards you. That's why this dot. If it is going away from you, I will show it as a cross. Is that clear? So the topmost point, the current is coming towards you. It goes like this, goes behind, goes from the top, again it goes round and round. Artha avite? Everybody? All right. Okay. Now, idu nodi. All right. Observe carefully. This is basically, this is basically the radius. This is basically your x. This is x. This is r. Now, imagine I join a line like this. It's completing a right angle triangle. Due to this element, by Biot-Savart's law, there will be a magnetic field at this point. There will be a magnetic field at this point. Let's understand where it will be. I will call this as small r. The Biot-Savart's law says that the magnetic field at this point, due to the small element, the small field will be dB. It will be mu naught by 4 pi I dl by r cube into r. This is what the formula is for Biot-Savart's law. There is a cross product involved here. Length is towards you. R is the position vector. It is like this basically. So whenever I do cross product, A cross B, thumb gives me the direction. So think about it. If one vector is here, other vector is here, my fingers will go like this, then turn like this, thumb goes here. But one vector is here, other vector is like this, down. So I will curl my fingers at an angle, not like this horizontally, but I will turn it slightly at an angle. So my thumb will go over here. So look at it, dl vector towards you, r vector like this, dl, r is not here, r is there. So dl cross r goes like this. So therefore, my dv vector will be over here. This will be my dB vector. That is very, very important. It is in this particular direction. The angle between dl and r, dl is here, r is not here, it is like this. If you see carefully, it is 90 degree in that inclined plane. dl is here, r is there, just visualize in that inclined plane. Yes, the angle between them is actually 90 degree. So strictly speaking, it will be mu naught by 4 pi. This will be sine 90, the cross product. So it will be dl, r and r will cancel, dl by r square. dl by r square, correct? This is what the dv value will be. This is what the dB value will be. Okay. Now there will be many such dBs. Each dB, think like this, each dB will have two components. One component will be here, the other component will be here. There will be some other dBs somewhere below which will be like this, who will have again two components, one component here and the other component like this. For every point here, there is an opposite point here whose dB is here and here. This dB produced by this point, this element here produces magnetic field here. Each magnetic field has two components. Which one of them will you think will cancel? Think, the one on the top, the current which is going towards you is producing the magnetic field like this. The same wire, when it goes below like this, the current will produce a magnetic field this way. This magnetic field has two components. This magnetic field again has two components. Don't you see this and this, X and X, same direction will add. This vertical components cancel. Exactly. So these components will end up cancelling out each other and these components will basically add. That's what you will write down. They will add. So you will only be worried about to find the net magnetic field. You will be only worried about this particular component, the horizontal component. Yes, you will be only worried about the horizontal component. How much is that horizontal component dBx? Let's find out. This is theta. Let me do one thing. Let me write another line like this. Okay, so if this is theta, this is 90 minus theta. Automatically this is theta. This is 90 minus theta. This is 90. So this is theta. Theta 90 minus theta, because if this is theta, this is 90. From 90 you take out theta, this is 90 minus theta. This is 90. This is 90 minus theta. Naturally this is theta. Theta 90 minus theta, 90. This is theta. This is 90. So 90 minus this theta will be 90 minus theta. If this is 90 minus theta, this is 90, this is theta. Everything, theta 90 minus theta will go hand in hand. So what I will do next is, in order to find the net magnetic field, can I say it is the addition, it is the sum of, or basically the integration, sum integration is the same thing, of all the x components of dB, dBx, for all the currents. Every current over here, the x component only will add, the other components will cancel out. It will not be relevant. How much is that dBx? We just saw it is nothing but take your dB and just take the cos component of it. This is cos theta. This would be the sin theta component. So dB cos theta component. Why cos? This is closer, adjacent. Adjacent is cos component. The one which is not adjacent, it is sin component. Okay, let's see what happens next. Integration, this whole thing will come as it is, mu naught by 4 pi I dl by r square into cos theta. What is cos theta? Look at this triangle, adjacent by hypotenuse. Adjacent is r, hypotenuse is small r. That is what cos theta is. Many things are constants here, like mu naught by 4 pi is a constant, current is a constant, even radius is a constant, even small r is a constant. No matter where you go, here, here, or here, or here, this distance is always the constant. It's like a cone. I hope you are able to visualize. This is like a cone. This is the slanting surface, which is the same for all the sides of the cone. So even this r is a constant, so it will become r cube. Inside, I am just left with integration of dl. Nothing else is there. Nothing else is there, my dear students. So this will become mu naught I r divided by 4 pi r cube. What is integration of dl? That means you have to add all the lengths on that wire. It is the circumference. It is just the circumference. Yes, it is just the circumference. It is just the circumference of that wire, which is 2 pi r. which is just 2 pi r. So this will become 2 pi cancels, mu naught I r square divided by 2 r cube, which is mu naught I r square divided by 2. What is small r? The hypotenuse. So use Pythagoras theorem. R square plus x square raised to half, but it is also raised to 3. So put 3 over here, right? This is only because this small r is r square plus x square whole raised to half. So the whole thing raised to 3, that means it will become 3 by 2. That is the answer. Everyone clear? So start off by taking the element on the top, use Biot-Savart's law. The direction is like this. Find the magnitude of it. The angle between DL and R is in this plane, 90 degree. So sine 90 will be 1. Cancel that R. Take the cos component because the sine component will cancel with another identical element below, which will give the magnetic field like this. The horizontal components will add. So the total magnetic field will be the sum of only the x components, which is the cos components. Cos is adjacent by hypotenuse. This dV, we found it here, just substitute it here. The integration of the length, because everything else is a constant, goes outside, is adding all the lengths on that wire, which is circumference. Cancel out, you get the answer. Also use Pythagoras here. All right, fair enough. Let's go to the next question. Two lenses of some power are in contact with each other, forming a combination. What is the focal length of this combination? An object is given, then find the position, the size of the image and all of that. Okay, let's try to do this. Let's create a duplicate and all that. Okay. Maza bandhu, everyone? Yeah, I hope you are enjoying the class. All right, great. Okay, so let's see. Two lenses of some power are given and they are placed in a combination. Whenever the lenses are in combination, the effective power is just the sum of the powers. So P1 is 15, P2 is 5 with negative sign. So therefore the effective power will be just 10 diopters. But power is 1 by F. Power is 1 by F. This is effective power, focal length. So therefore the effective focal length will be 1 by 10th of a meter, which is 0.1 meter, which is 10 centimeters. So what is the focal length of this combination? The answer is 10 centimeters. So A part is done. A part is done. So you got 2 marks for that. 2 marks for this. Now remaining 2 marks for this. You have to find where the image is. So which formula will you use? Lens formula. What is lens formula? 1 by V minus 1 by U is 1 by F. Here you will use effective focal length. Where is the image? I don't know. Object is placed 30 centimeters from this combination. That means object distance is negative 30. If you are wondering why negative 30, let me tell you that also. Imagine this is some lens combination like this. The object is over here. This is the negative side. The rays from the object will come like this. So this is the negative side. This is the positive side of that lens combination. So image, I don't know where it is. Object distance is negative 30. Okay, focal length. We got it already as positive. So it will be just 1 by 10 over here. So 1 by V is equal to 1 by 10 minus plus. Plus 1 by 30, take it over here. It will become minus 1 by 30. What is the LCM? It is 30. 10 goes with 30 3 times minus 1, which is 2 by 30, which makes 1 by V as 1 by 15. So 1 by V is 1 by 15. That means V is equal to 15 centimeters. Because it is positive 15, that means the image is formed somewhere over here. Image is formed 15 centimeters away. But that is not the end story. The end story is what is the size of the image. So you have to use magnification formula, which is V by U. So magnification is also height of the image by height of the object. Image distance is 15. Object distance is negative 30. Image height, I don't know. Object height is 3 centimeters. So what do you see from here? What do you see from here? Height of the image will be 15 multiplied by 3 by minus 30. 3 goes with 30 10 times. So it will be negative 1.5 centimeters. So basically it is 1.5 centimeters. The negative says that it is inverted. That's all. It is just inverted. The height of the image is 1.5, just that it has been made upside down. That is the meaning of the negative sign. That's all. Minus 1.5 centimeters, 15 centimeters. Okay, perfect. We have got the correct answer. Got it, guys? How to solve this question? Artha aite? Ellaru? Everyone? Okay. Let's move to the next question. It says that there is a parallel plate capacitor with some air between them. The total capacitance is 9 picofarad. Separation is D. Space between them is filled with two different dielectric medium, 3 and thickness D by 3. Other is 6 constant having a thickness of 2D by 3. What is the total capacitance of the capacitor? Let's try to do this. Okay. First of all, let's start with the diagram, my dear students. Start off with the diagram. Okay, this is our capacitor. This is 9 picofarad. The distance between the plates was D. Now what you are doing, you are making it into two separate capacitors. One is D by 3, other is 2D by 3. So D by 3 is the length and 2D by 3 is the length here. You are filling it up with some dielectric medium. And what is that medium? Constant. It is 3. Here K1 is equal to 3. Here there is some different medium. What is that K? It is basically 6. Okay, perfect. Question is find the capacitance of the capacitor. Alright, let's do. If you see both of them, if I call this as C1, this is C2, both of them are one after the other and they are in series. They are basically in series. So C1 and C2 are in series. So 1 by CS is 1 by C1 plus 1 by C2. Whenever capacitors are in series, their formula is like resistors in parallel. Be careful or else you will add C1 and C2. What is the formula for capacitance? In general, whenever you have a capacitor with some medium of constant K, the capacitance is epsilon naught A by D and there is K over here. This is the formula that you need to remember. So epsilon is epsilon into K. K is basically 3 into area divided by D. Here distance is D by 3. So I'll put D by 3 over here plus. Next, capacitance number 2. Epsilon naught into dielectric constant, which is 6 into area. That's how it is. Epsilon naught AK by D. Epsilon naught AK by D. Distance is 2D by 3. Okay. 2D by 3 over here. Fair enough. Now let's do one thing. Let's take out epsilon naught common. A is also common. D is also common. Over here, this 1 by 3 is there. This 3 is there. Plus here 2 by 3 is there and here 6 is there. Deliberately I am doing all this. You will see why. D by epsilon naught A. This will become 1 by 9. 3 3s are 9. Here this will become 2 and 6. Will cancel. It will become 1 by 3. Again it will become 1 by 9 over here. So therefore 1 by CS will become D by epsilon naught A. 1 by 9 plus 1 by 9, 2 by 9. 1 by 9 plus 1 by 9, 2 by 9. Flip it over. Capacitance will become epsilon naught A by D 9 by 2. 9 by 2. I hope this is absolutely clear. Now, what is the next step? See this epsilon naught A by D. This is the capacitance of this guy. Epsilon naught A by D is basically the capacitance of nothing but this guy. So this is just nothing but 9 picofarad multiplied by 9, whole thing divided by 2 is the effective capacitance. So 9 nines are 81 by 2, which is going to give me 40.5 picofarad. 40.5 picofarad. Very easily we have got the answer. Okay, so that is what it is. I hope this is absolutely clear. Shall we go to the next question? All right, here comes the next question. A point charge is causing some electric flux of this much Newton per coulomb into meter square to pass through a spherical Gaussian surface of some radius centered on the charge. If the radius were doubled, how much flux will pass? What is the value of the point charge to pass through a spherical Gaussian surface? Okay, so imagine a Gaussian surface like this. Okay, let's duplicate this first of all. This is a spherical Gaussian surface, and imagine there is a charge over here, and it is being said that the electric flux passes through the sphere like this. It is entering here like this. So the law that you will be using for solving this problem is the Gauss's law. Nothing else is there, correct? So using Gauss law, the total flux through the sphere will be the charge which was placed inside by epsilon naught. The flux is already given to be 10 to the power 3. The charge inside is not given. Epsilon naught value is 8.85, 10 to the power minus 12. Because the flux is entering in, this flux will be negative sign. Take this over here. So this will become 8, negative 8.85, okay, into 10 to the power minus 12 into 10 to the power 3 is equal to the charge which is placed. So that charge will be minus 8.85 into minus 12 and plus 3 will make it 10 to the power minus 9. Minus 9 is basically nano. So that many nano coulomb is the charge. So what is the, how much, what is the value of the point charge? That also we have found. Okay, what is the value of the point charge? We just figured it out, 8.85 nano coulomb. You can see that right over here also. It is there, 8.85, 10 to the power, sorry, it is 10 to the power minus 9. Yeah, so there is, I think, a mistake of the powers over here. They have forgotten the minus sign. Yeah, but it is 10 to the power minus 9 nano coulomb. Okay, this is done. Next part, if the radius of the surface were doubled, how much flux will pass through the surface? See, even if you double that radius, whatever lines were passing here, are passing through even the other surface. So whether you take bigger sphere, smaller sphere, doesn't matter. The charge enclosed is the same. Since the charge enclosed is the same, so the flux is also going to be the same. So the first answer will be how much flux will pass. The answer for that will be exactly this one. Same flux, because same charge is there inside. Same lines are going to pass. No different, no new, no line is omitted. It is the same flux. Hence the answer is same. If the charge of 2 picocoulomb is at the center of a cubic Gaussian surface, find the electric flux through the surface. All right. So if you have a charge like this and it is at the center of a cubic Gaussian surface, doesn't matter whether it's a cube, pentagon, hexagon, as long as it is closed, the total flux will be charge inside by epsilon naught. Charge inside is 2 pico. Pico is 10 to the power minus 12 by 8.85, 10 to the power minus 12. Minus 12 cancels. It will be 2 divided by 8.85, which is approximately going to be, just check this out, it will be 0.9, 2 by 9, right? So yes, 0.2 something, 0.2 something approximately. Yeah, just check this out. Yeah, this is what it will be. Charge is, I think they have taken wrong answer over here. Yeah, minus 12, they have put it as minus 6 anyways. it was pico, guys. Pico is 10 to the power minus 12. Yes, so here I'll just delete the slide later on. The answer should be 0.226. That's it. It should be 0.226. 0.226 Newton per coulomb meter square. That's it. This was pico coulomb. Yeah, it was not micro. So it is 10 to the power minus 12. Perfect. This is correct. 0.226 Newton per coulomb meter square. Awesomeness. Moving on to the next question. There is a tank filled with some liquid to a height of some 12.5. Apparent depth is 9.4. What is the refractive index? See, if you have a tank filled with some liquid and it is clearly mentioned the height is 12.5 centimeters, but you see that there is a needle at the bottom of the tank as measured by the microscope to be 9.4, meaning you see the image over here. You see the image to be over here, which is 9.4 centimeters. This is apparent depth. This is apparent depth where the image is formed. And we know there is a formula. There is a formula which says actual depth upon apparent depth is the refractive index of the liquid. So the apparent depth is 9.4. The actual depth is 12.5. That will give me the refractive index. Therefore, the value of mu, which will come out to be 12.5 by 9.4. Come on, do the math and see if you are getting the answer as 1.33 approximately. You should get it as 1.33 as the refractive index. So this is the first answer which we just found. What is the refractive index of that water? This is the refractive index of water which we have got over here. Perfect. If this same water is replaced by some other liquid now, it is replaced by some other liquid of some refractive index, what distance will the microscope have to be moved? Okay, so see guys, now you use some another liquid, same height, but refractive index is different. This is 12.5 centimeters. Now you will see probably the image is somewhere here. This will be the new apparent height. So using this formula, the new apparent height will be the actual height divided by mu. Apparent will be actual divided by mu. Okay, what is the actual? It is 12.5. Mu is 1.33. Sorry, it is not 1.33 anymore. It is new liquid, so 1.63. 1.63. So what is that apparent height going to be? Do the math. 12.5 by 1.63. It will be slightly less than 9.4. It will be slightly less than 9.4. Just see if it is coming out to be 7.67. Just check if it is coming out to be 7.67 centimeters. So now the image has moved 7.6 centimeters below the surface. Earlier, it was 9.4 below. So this is very, very important. The liquid surface is here. Earlier, it was seen at a distance of 9.4. Earlier, it was seen at a distance of 9.4 below the liquid surface. Now, it is seen at a distance of 7.6 below the liquid surface. So, the obvious thing is seen over here. This is the shift. This is basically the shift, guys. This is basically the shift. 7.67, you can approximately take it as 7.7 also. So this will also become 7.7. So the shift which will occur, the image has shifted. That is exactly the shift distance of the microscope. You have to move it basically. You have to shift that microscope exactly by that distance, which is 9.4 minus 7.7. I hope this is absolutely clear. This minus this will be the shift. How much will this come out to be, my dear warriors? It's like 94 minus 77. Yes. Yep, it will be 1.7 centimeters approximately. 1.7 centimeters approximately. Is that right, everyone? I hope this is very, very clear. All right. Awesome. So that was that answer. Next question coming up on your screen. It says deduce the condition for balancing a Wheatstone's bridge. For balancing a Wheatstone's bridge using Kirchhoff's laws. Okay. So for this, start off by drawing the Wheatstone's bridge like this, like this, like this. Okay. This is one resistor, this is one resistor, this is one resistor, this is one resistor. Let's say this is R1, let's say this is R2, let's say this is R3, let's say this is R4, and then there is a galvanometer which also has some resistance. I can call it as RG. Okay. First you show the diagram. Then what you will say is that because it is clearly mentioned that the condition for balance means no reading or basically null deflection. No deflection, null deflection is the same thing. Null deflection in the galvanometer. No deflection in the galvanometer. That will only happen if there is no current only. The current through the galvanometer is 0. So there is no current only in this branch. If that has to happen, it will only happen in one condition. Whatever current is entering here, let's say I current is going here, that same current goes here, same current goes here. Now it will get distributed in two branches. Let's say this is I1, let's say this is I3. After reaching here, it can't get distributed further because no current only is going here. So this same current I1 should pass through R2 and the same current I3 should pass through R4. And again they will collect back. This will again become I, this is I, and this is also I. This is the first thing that you will do, and from this you will immediately understand, since there is null deflection, Ig will be 0, no current here, therefore you will just say I1 and I2 are equal. I1 will be equal to I2 and I3 and I4 will be equal. I3 and I4 will definitely be equal. This is what you will do. Everybody clear till this point? Absolutely clear? Perfect. Now next step. You choose loops. You choose loops. First loop, choose this triangle. If you want, I will label it. If you want, I will label it. Let's say this is A, this is B, this is C, this is D. Choose the loop A, B, C, A. Choose the loop A, B, C, A for applying Kirchhoff's voltage law. For applying Kirchhoff's voltage law. Observe. As you are going through the resistor in the current direction, you will drop the voltage, that means negative. Current is I1, resistance is R1. In the direction of the current, you drop. Against, you put plus. Here, there is no current, no drop at all. So put 0. Here to here, you are going against the direction of the current. So plus I3 R3. Because you are coming back to the same point, it is 0. So therefore, I3 R3, take this guy on the other side, is equal to I1 R1. Therefore, I can say I3 by I1 is equal to R1 by R3. Just keep it as it is. Don't do anything. Now, next, consider the loop, this one, BDC, B, D, C, B. Apply Kirchhoff's voltage law again. B to D in the direction of the current, so I2, and it will be negative because it will drop. I2, R2. Here to here against, so it will be positive. So I4, R4. Here to here no drop because current is 0, plus 0 is equal to 0. Take this on the other side. So I4, R4 will be I2, R2. Therefore, I4 by I2 will be R2 by R4. But what is I4? I4 is I3. What is I2? I2 is like I1. Will be R2 by R4. I3 by I1, I3 by I1, R1 by R3, R2 by R4. Therefore, from both these equations, equation number 2 and equation number 1, what does equation number 1 and 2 tell you? LHS is same, so RHS should be same. So R1 by R3 is equal to R2 by R4. So this is your condition. So we have used Kirchhoff's laws and also distribution of currents to solve the problem. I hope this is understood. So use the same method in the exam, you will get full 4 marks. You will get full 4 marks. Next question. There is a conductor whose radius is basically 12 centimeters, has a charge of this much, which is there on the surface. What is the field inside, outside, and at a point 18 centimeters from the sphere? Okay. So this is our sphere, let's say. So first, let's solve for inside the sphere. Whenever you have such a diagram, this is basically the charges which are there on the sphere. Radius of the sphere is also given. Yes, 12 centimeters. So if you are at a point inside, okay, inside a shell, there is no net field. There is no net electric field. Very, very important thing which you have already learned. Inside a shell, hollow sphere, there is no electric field. So the answer for A, the first answer will be a big fat 0. So A is done. Inside the sphere, there is no electric field. That was the easiest of them all. Probably you will get 1 mark for that because it is easy. Maybe now just outside will have 2 marks, at 18 centimeters will have 2 marks. You have to see the distribution. Accordingly, you will solve. Just on the surface, just outside the sphere means just on the surface. So now for electric field at point B, it's electric field on the surface. It will be KQ by the radius of the sphere square. K is 9 into 10 to the power 9. Charge is 1.6 10 to the power 7 divided by distance, which is the radius, which is 12 centimeter, which means 0.12, or you can also say 12 square into 10 to the power minus 4. Or if you don't like it like that, no issues. You can just put 0.12 and then whole square. It is in meters. That is going to give me calculating the electric field on the surface. You can do the math, you will get the answer. This is how you do the next part of this. This is how you do the next part of this. Now you might be like, sir, how do I do the calculation? Well, we can do some small things over here. 9 into, let's do one thing, let's create a duplicate. Okay. So this I can also write it as excuse me, 9 into 16 into 10 to the power 9 into, because I took out one decimal, so I have to write 10 to the power 6, whole thing divided by 12 is 3 into 4. Square of 3 is basically 9. Square of 4 is basically 16. Decimal places were 2 decimal places, so 10 to the power minus 4. Do you understand why I did this? Because 12 is 3 into 4, 3 square 9, 4 square 16. 2 decimal places squared will make it 4 decimal places. 9, 9, 16, 16 cancels. So this will become a very easy number to calculate. 4 goes on the top. 4 basically goes on the top, right? It will just become plus 4 plus 6 plus 10. So it will become 10 to the power 19. 10 to the power 19 Newton per Coulomb. That is the answer for this particular thing. Okay. Now this is also done. Okay, this part is also done. Now let's do the last part. Let's do the last part. Last part is at a distance of 18 centimeters or something it is given, if I'm not wrong. So this was also done. Now I want to find it over here. How far is that point? 18 centimeters. Okay, at a distance of 18 centimeters. So electric field for C, which is electric field outside, is kq by r square. K is 9, 10 to the power 9. Charge 1.6, 10 to the power 7, guys. Whole thing divided by r. R is 18. So 18 square, but it is centimeters. So 10 to the power minus 2 meters, and square it over here. Okay, let's see what we can do over here. 9 into 16 into 10 to the power 9 into, since I have shifted one decimal, inside, so it should be just 10 to the power 6 divided by 18 is 9 into 2, 9 into 9 and 2 into 2 into, this will be 10 to the power minus 4. One of the 9, just you can clearly see, has just got cancelled. This 2, 4 goes with this as 4. So I am just left with 4 by 9 into, goes on the top, becomes 6 plus 4, 10 plus 9 will make it 10 to the power 19 Newton per Coulomb. So that is the electric field at point number C. This is also done. All these things are also there over here. Okay, so this is also done. Great. So now there is one more question which is there as homework. Guess what? We have done a similar question previously. You can find the video solution on this channel. That is up to you. That is the challenge for you. Solution and the answer is there on the next slide. Yes, it is there on the next slide. Main thing is, did you see a lot of new concepts, how problems are solved for HOTS questions? And you can see it is a very good level of questions like your JEE or NEET examination also. So when you are preparing for KCT or PO boards, you are automatically preparing for many other examinations. So given your 100%, because a good college seat is guaranteed with the right approach. If you found that, sir, these questions I was not able to understand because my basics only are not clear, don't worry. After a few days, we will start, from the basics theory teaching series also. All right. But hopefully you had some knowledge and you were able to build upon that in these questions. If you enjoyed it, make sure you are liking, subscribe, Madi. All right. Well, please do that. It means a lot. And also comment below what you want next, okay, in the days to come. Thank you so much. This was Captain Shreyas signing off. Bye-bye. Take care.